Hello everybody, my name is Dr. Sergey Sarkisov, and today we will prove the quadratic formula, which is a solution to the quadratic equation. Therefore, let us assume we are given, or we have put our quadratic equation into standard form. In other words, here's a coefficient a times the variable squared, x squared, plus the coefficient b times the linear term x, and then plus a coefficient or constant c. And let's say that's now equal to 0. So we got everything on the left side, on the right side, there's 0. Now this is standard form of a quadratic equation. Standard form of quadratic equation. Okay? The quadratic equation. Now, how do we go from here to find a solution? And we even expect two solutions, right, to the variable x, two solutions that will work. And often we get that and we're wondering, well, why is that the case? Let's see, what would be the first step to simplifying this so we could prove our quadratic formula? Well, often we have learned about completing the square. That's when we have a square term, x squared, plus a power of x to the first power, so x squared and x, and then we have basically like a parabola and a line kind of added together, see right here? And we're wondering, how do we make sense of it as far as how can we put it in one quantity, in one idea together? In other words, let's make it all a parabola. That's the idea. That way we can have some kind of simplification happen. So let's do this. First, let's get rid of the coefficient a in front of x squared. And to do that, we can't just get rid of it. Let's divide the whole equation, in other words, the left side, the right side, to be fair to both sides, by a. So we will get what? X squared, get rid of the a, plus now b divided by a will be x as b over a, x, right? And then plus, well, we have c divided by a now. And what's 0 divided by a? It's still 0. So what we did is we have divided both sides of the equation by coefficient a. Okay. Now what we can do to further along the process is complete the square. This is the trickiest part, I believe, sometimes. The trickiest part of the quadratic equation solution and deriving the quadratic formula will be the completing the square procedure. So what we do is we see these two terms, x squared and the x term, b over ax, right? Let us put it in another form, and what we can do is let's say that something's squared, right? So it's x plus some number, right? Right here, some number. That when I square it, I'm supposed to get that x squared plus b over ax. How do I do that? What does this what quantity will it be? Well, let's first look at what would this equal to. Let's say I have this underlined squiggle. And so what happens is if I expand it, and we should know now that x plus something squared is x squared plus 2 times that something times the x, okay? And then plus, of course, that's something squared, right? Whatever that something is. It could be a box for all you want. So x plus box squared will be x squared plus 2 boxes squared, boxes, times x plus box squared, right? So look, when we get this x squared, that's good. We get this to something x, right? That would be nice. But this is, what do we do with this, right? That's an extra term in a sense. We don't have that up there. I only underline an x squared and an x term. So what we can do is, what we can do is this. We can say, okay, well, what is x squared plus a 2 box, right? X plus a box squared. If I get rid of the box squared now, right? We just want the 2 box x. So x squared and x term, the quadratic term and the linear term. To do that, let's get rid of the box squared. So we have equals to what we have on the left side, and I reverse, of course, the sides here. And then, of course, take away the box squared, right? And you see that's exactly the same thing. Well, now what we have is x squared plus a b over a, right, x. And what is that equal to then? Well, it's x plus, this is one box here, right? Whereas this is two boxes here, x. So what's half of b over 2a? b over a, I mean. It's b over 2a. See how we go from 2 to 1 here? Well, we divide by 2, right? So from b over a, we get to b over 2a. And then when we square it, let's get rid of box, this right here, squared. And that's going to be minus b squared all over what? What's 2a times 2a? It's 4a squared, right? Okay. So that is exactly now another way of writing x squared plus b over ax. So let's do that. Let's write it that way, as in we have completed the square and we get x plus b over 2a, over 2a, okay, all that, and then squared minus a b squared minus all over a 4a squared. That's going to be the underlined portion there, the linear and the square term added together now, just being basically a square term and a number, right? Because that's a constant. B squared over 4a squared is a constant. There's no variable there, okay? So we have that, and then of course plus a c over a is still there, right? So we match that up, and then plus a c over a, and that's equal to 0. What we have done here is we completed the square. Okay. In other words, we made a square out of just out of a combination of a square and a linear term. Okay. So now what do we do? Well, let's isolate this x plus b over 2a squared quantity. So, all right, this expression leaves us to have what? X plus b over 2a. Now, how do I isolate this? Well, I get rid of this b squared over 4a squared. Now, since it's a minus, let's add it to both sides. So, okay, b squared over 4a squared, right? And then how do I get rid of the c over a? Well, subtract it from both sides. Now look, what happens is I have just x squared material on the left side, right? The expression x plus 2b over 2a squared. How do I get rid of what? The x plus b over 2a? How do I get rid of the square? Let's take the square root, right, of both sides. In other words, if I had asked you, well, what is x squared equals to 9? And you would tell me x is equal to plus or minus the square root of 9, which is plus or minus 3. Don't forget the plus or minus. There's something called the square root property, right? Square root property, okay? So by that square root property, we have now what? X plus b over 2a without that squaring, right? We don't square that anymore. And that's equal to plus or minus the square root of all this material here. And what is b squared over 4a squared minus c over a? Let's see. B squared over 4a squared minus a c over a. Let's make it a little more easy to look at, put it together. So this is a fraction, and we combine like terms, what happens? It's b squared over 4a squared, right? Make a common denominator of 4a squared, right? We already have an a there, so times 4ac, times 4a here at the top and 4a at the bottom. And now we have a common denominator of 4a squared, as you can see, and that's equal to b squared minus a 4ac all over that 4a squared, right? So now let's put that there. This is what do we do? We just add and simplify, basically subtract two fractions, right? So we have x plus a b over 2a is equal to, just rewriting it in the other way we've gotten this expression to look, which is b squared minus a 4ac all over a 4a squared. And we remember from earlier that what happens here is that when we have a square root of something that's a fraction, it's the same thing as saying, okay, well, the square root of the numerator, b squared minus 4ac, all over the square root of the denominator, okay? What's the square root of 4a squared? Square root of 4 is 2 comes out, right? Square root of a squared, and a comes out, okay? So instead of writing the square root of 4a squared, I'm going to write 2a, okay? So now we have this. What can we do? Look, I want x. Remember, I've almost solved this. I actually have almost proven the quadratic formula. But now I want just the x, right? So my x is equal to, get rid of the, let's simplify and isolate the variable. So isolate the variable. Okay. So let's do that. This is isolate the variable. and x is equal to, take away the b over 2a, so minus b over 2a, okay, plus or minus the square root of b squared minus a 4ac all over 2a, right? Now, what we can do here is combine these fractions. They have a common denominator already, 2a. And so x is equal to negative b, right, plus or minus the square root of what? B squared minus a 4ac, all that together, all over 2a. You know what this is? We have just derived the quadratic formula. Wow, right? This is the quadratic formula that so many of us always talk about, and we never really understand where it comes from sometimes. This is a derivation. This is a proof that that's what the solutions to x are. Those are the solutions to x when you're given any quadratic equation. Now, remember, one thing you have to do is you have to initiate it with putting it in standard form. So let's do an example, quadratic formula, right? And so let me put this in a fancy box here because this is a big result. This is a quadratic formula. Okay? So let's do that, and let's do another one of these. It's a big result. Okay? That we've gotten. All right? That's a quadratic formula. Now, like I said, let's do an example. So, example, sample exercise could be, let's solve. Okay? Right? So, find the solutions to. How about what if I said 3x squared, okay, minus a 5x, okay, equals to 8. Okay? How do we solve this? And let's use a quadratic formula. Can this factor? Can we get something like that by using factoring and the zero product property? Yes. Okay? And to you is yes. But let's first do the non-thinking approach. Like, okay, here's a formula. Let's plug in the numbers. So let's first put this in standard form. Remember, and the standard form would be 3x squared minus a 5x. The square term and the linear term are already there. And then you want it equal to 0. So subtract 8 from both sides. Okay? Equals to 0. All right, great. Now what? Now what we're going to do is we're going to remember what we have the standard form, right? What are our a, what are our b and c? What are the coefficients? In other words, what are these constant numbers? So a is equal to 3, right? Like ax squared, so 3x squared. B is equal to, now adding a bx is now subtracting 5x. So we're negative 5 is for b, and c is now a negative 8. Now that we have these numbers set up correctly, we can go ahead and use the quadratic formula. Let's look up here. Negative b plus or minus the square root of b squared minus 4ac, and all of that over 2a. Okay, let's see what happens. So x is equal to negative of a b, negative 5, right? Plus or minus the square root of what's b squared, negative 5 squared, okay? Minus a 4a, which is 3, and c, which is a negative 8, right? Okay, and all that over 2 times a 3, 2a. Okay, so x is equal to negative of a negative 5 is plus a 5, right? Plus or minus the square root of what? What's 20? That's 25 right there, negative 5 squared. Still positive because negative times negative is positive. And what's minus 4 times 3 times an 8? That's what? That's 12 and 8 times 8. It's not times an 8. So that's 96 if I'm doing it correctly. And so adding a 96. Okay? So we have that, and then all over a 6, right? Now, what is this equal to? Let's see. This is equal to, now, let's combine those numbers. It's 5 plus or minus the square root of, what's that? That's 121, right? Yeah. 96 plus 25. And then all over 6. Now, look, this 121 is not a bad number. We know the square root of 121. Most of us do. It's 11, right? So x is equal to 5 plus or minus 11 all over 6. Let's see what numbers we get from here. So, in other words, x is equal to what? 5. Let's do minus first. Minus 11 over 6. Or, right, let's do the plus. 5 plus 11 over 6. Okay? So in other words, x is equal to What's minus 5 minus 11? What is 5 minus 11? Negative 6 over 6, right? And then, or we have, what's 5 plus 11? 16 over 6. In other words, our solution set is now negative 1, right? And then what is this? 8/3, okay? So, or 8/3. Those two are the solutions to this quadratic equation. And note that, what does it mean, solutions? It means if I plug in negative 1 into this quadratic equation, right? 3x squared minus 5x equals 8. It will actually have on the left side an 8, and on the right side an 8. It will work out. And you can see 3 times negative 1 squared is 3, minus a 5 times the negative 1 is actually adding a 5. 3 plus 5 is 8. And similarly, 8/3 will work. Now, how else could we have done this, this exercise, right? Is there another way we could have solved this? So let me show you this. Other ways to solve this quadratic equation. Okay? So are there other ways? And the answer is yes. There's two other ways that I stress, and these are the two that I require thinking, and I call them what? One of them is factoring, solving the quadratic equation by factoring, and the other one is by completing the square, which kind of incorporates, or even is kind of a preliminary result, because we've done completing the square to prove the quadratic formula, but we can do that directly, completing the square with numbers. Let's stick to one more example with factoring this. So let's do this. Factoring is a big factoring and the zero product property will be our one example of how we can solve this without the quadratic formula. Okay. And so, like I said, without, right? So this quadratic equation without the quadratic formula. So factoring and zero product property. Okay. Let's take the same quadratic equation. Let's see what was it? It was 3x squared minus 5x equals to 8. Okay. So we had 3x squared minus 5x is equal to 8, right? Let's put in standard form. I recommend doing it for this as well. It's really the way to do that. So we have 3x squared minus a 5x minus an 8 equals 0, right? And then what happens? Let's try to factor. And this is tricky. I usually encourage students to really put some insight into this factoring. So what we want to do is this. 3x squared, and you want some kind of x times some kind of x. You know, linear times linear to get the quadratic term. Now, 3, how to get the coefficient 3? What are factors of 3? I know 3 and 1 really factor or divide 3. And so that's the way we're going to write. There's really only one. It's a prime number. One combination would be 3 and 1x. Okay? 3x and 1x. And that gives you 3x squared when you multiply it. Now, take a look at this. There can be other numbers I can use, but I'm looking for integers that are easy in quotation marks numbers, because we actually can see the solution here wasn't so bad. In fact, I'll tell you this much. Because the solution here was negative 1 8/3, I could tell you right away, I know this problem, you could have done this by factoring, because we're getting rational, in other words, easy fractions. We're getting these numbers that are rational as solutions. It should have factored initially. So look, 3x times x is 3x squared, and then how do I get this negative 8? Well, you can try different combinations. What if I tried a minus 8 here and a plus 1 here? Okay. So again, negative 8 times plus 1, that works. You could have done a negative 4 and a plus 2. You could have done a 4 and a negative 2. Who knows, right? But the reason I can see this happening, and with experience, you'll see this much more quickly. That look, what happens is this gives you negative 8x, right? And what does this give you? 3x times a 1. That's a 3x, right? What's 3x minus a negative 8x? That's exactly this together would be a negative 5x as we want, right? And of course, the outer terms are negative 8 and what is it? 3x squared. So those are working, these are working, and then this is also working, right? Okay. So with that, we have basically a new equation. 3x minus 8 times x plus 1 is equal to 0. And what happens? If we have two numbers, if two numbers a times a number, or let's call this w times z, if these are equal to 0 multiplied, then one of them has to be 0. In other words, w equals 0 or z equals 0. So what do we do now? Our w is 3x minus 8. So 3x minus 8, and it's equal to 0. Now this is a linear equation. We've simplified this a lot, right? Nothing quadratic about this. Or we have that other z, which is x plus 1, equals to 0, right? And so let's solve for x both places, and we have here x is equal to, look, 8 on the right side divided by 3, get rid of the coefficient in front of x. Or we have 8 thirds, or x is equal to -1. And that's how we have the solution, -1 and 8 thirds, right? But I'm in increasing order. And you may wonder, well, is this right? Is this wrong? Maybe we made a mistake somewhere. Look at this, -1 and 8 thirds. There's -1 and 8 thirds right there. We had it. We did it 2 different ways, and we got the same answer. And we should have had the same answer if we did it correctly both ways. However, today's lesson was most importantly deriving the quadratic formula from the quadratic equation. And you can see that this actually will solve any quadratic formula anytime. Even if you get a square root of a negative number, and you may think, well, that's not really a solution, you can still consider it as an imaginary as part of the solution, and you'll have a complex number with an imaginary part. And remember, the square root of a -1, we label that as I. Okay. Well, thank you so much for being here today, and I hope you've learned how to derive the quadratic formula.